Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding. Question 9. We need to find the change in power dissipated in the 4 ohm resistor after the switch S is closed. So we can see there is a circuit. It has 4 ohm, 8 ohm resistor, 8 volt and 4 volt battery, and there is a 2 ohm resistor which is connected between Q and P, but there is a switch that is open first. We need to find out the change in power through the 4 ohm resistor. So case 1, when S is closed. So when S is closed, we can find out the current passing through the 4 ohm resistor as I by using the Kirchhoff's current and voltage law. So applying KVL, in the loop, let me just give the names to the nodes A, B, C, D, A. So we are applying the Kirchhoff's voltage law across this loop. So it will be minus 4I minus 8I, and then when we'll be entering this battery from the negative terminal, it will be the positive voltage drop, plus 8. Again, we are entering the battery with the negative terminal, so there will be a positive voltage drop, plus 4, that must be equal to 0. So when we solve this out, minus 12I is equal to minus 12, and I will be equal to 1 ampere. So power dissipated through 4 ohm resistor P across 4 ohm, that will be equal to I square into R. So I is the current flowing through 4 ohm resistor, that is equal to 1 ampere, and we have to multiply the square of it with 4 ohm. That is equal to 1 square multiplied by 4. It will be equal to 4 watt. So when switch S is open, 4 watt is the power that is dissipated through 4 ohm resistor. Now let's close the switch and find out the power dissipated in 4 ohm again. So when we close this up, the current I is flowing through the 4 ohm resistor, and it is divided into I1 and I2. Now again we need to find the power dissipated using the Kirchhoff's law. So using KCL at Q, we can write I is equal to I1 plus I2. I is the current that is reaching this node, and I1 and I2 are going out from it. Now let me give the names to the node, and we will be finding out the current I using KVL. So using KVL in loop A, B, Q, P. So we are entering the 4 ohm resistor along the loop itself. So it will be minus 4I and then minus 2I1, that is plus 4 is equal to 0. We are entering the battery with the negative terminal, so plus 4 voltage. So it will be 4I plus 2I, 1 is equal to 4. This is equation number 1. Again, using KVL in loop Q, C, D, P, Q. So we are moving from Q to C, then C to D, then D to P, and P to Q. So I2 is the current that is passing through 8 ohm. So minus 8 I2, and we are entering this battery with the negative terminal. So plus 8, and here when we are moving from P to Q, we are against the direction of current. So that will be plus 2I1, and that is equal to 0. So this will give us 2I1 plus, sorry, minus 8I2, that is equal to minus 8. This minus 8 will go to that side. Now we can do some manipulations. This I, it can be replaced as I1 plus I2. So using I is equal to I1 plus I2 in equation 1, we can write 4 times I1 plus I2 plus 2I1, that is equal to 4. So it will be 6I1 plus 4i2, that is equal to 4. Now we can multiply this equation by 3 in order to make the coefficient of I1 6. So this equation on multiplication with 3, it will be 6i1 minus 24i2, that will be equal to minus 24. So when we solve this out, these two equations, I'm marking it as 3 and 4. When we solve 3 and 4, it will be minus and gets cancelled out. It will be plus. So 28i2 will be equal to minus, and it will be plus again. So that will be plus 28. And I2 will be equal to 1 ampere. So we got from this that I2 has come out to be 1 ampere. Now we can use the value of I2 in this equation. Minus 8i2 plus 8 plus 2i1 is equal to 0, and we can find I1 as well. So let's put I2 in this equation and find I1. So it will be minus 8 into 1, that is minus 8i2, plus 8 plus 2i1, and that is equal to 0. So from here, we can find out minus 8 plus 8 plus 2i1 is equal to 0. And this will give us that I1 is equal to 0. So when I1 is 0, it means this thing that in the 2 ohm resistor, no current is flowing. So when I1 is 0, it means even if we close this, the I1 is equal to 0. That's what we have obtained. No current is flowing through 2 ohm resistor. And I, now it is equal to I2. So I2 was 1 ampere. So I will also become 1 ampere. So even when S is closed, current in 4 ohm resistor is 1 ampere. So again, power dissipated will be I square into R, and that is equal to 1 square multiplied by 4. It will be 4 watt. So in both the cases, the power dissipated in 4 ohm resistor is 4 watt. So power dissipated will remain same. So when the switch S is closed, then also it is 4 watt. And when it is open, then also it is 4 watt. No change in the power dissipation through 4 ohm, as the current through the 4 ohm is 1 ampere in both the cases. Thank you. Keep learning, keep practicing, keep excelling.